All right, so this is Foundations Math 20, 4.3, number 9, right? FM 20, 4.3, number 9. Okay, so part of a highway is to be cantilevered out. Is it frozen still? Sorry. All right, there we go. So part of a highway is to be cantilevered out from a mountainside. Now, cantilevered means that they will have a solid beam that kind of goes into the mountain a little bit, and it'll extend out. Okay, so that the pressure on the pressure on the, I'll see if I can do this. The pressure on the one side, like this, pressing down, will press up on the other side. So if you have it inside the mountain a little bit, the pressure down will cause the pressure go up, and it'll stay. It should stay solid. Like if you have a deck on your house, like let's say an upper deck, you don't have like wood supports on the outside. It's just like, looks like it's just coming out from the house. That's because the beams that are underneath the deck also go into the house, right? And so they're supported there, so you don't have to have a support out here. Now, there's going to be, in this question, there's also going to be a support beam for safety. So they're going to put another support beam. A single support beam would not be enough, but this beam kind of goes into the mountain, probably looks like this. They drill it in, right? So this is one solid beam, but they want some kind of support beam out here, okay? So like here or here or here. So what's the best? How is this going to look, right? So there could be a number of different positions where you could attach this support beam. Obviously, if the angle is too small like this, it's probably going to be not much of a support beam, is it? Right? But if the angle is too large, if it's close to 90, like this is the side of a mountain, so they might have to make it like 500 feet long, and then it's not going to be very solid. So where is a good point to kind of attach it that will give it some support, but also not be too long or whatever? Okay, let me read the question. The width of the highway is 22 meters. So this is 22 here, okay, the width of the highway. And the angle of the mountain slope at the road measures 51. So the angle of the mountain slope, let's just draw this right here, is 51. I think that's where you want to put that right there. An 18-meter beam needs to be installed to support the highway. So if you're drawing this to scale, if this is 22, 18 is going to be a little less than that. So it's going to be, maybe somewhere around here, right? That's going to be maybe 18 compared to this 22 or so. Calculate the possible distances downhill from the highway. So the possible distances from the highway down the hill, here, or other places where the support post could be fastened. What distance would you recommend? Explain. Okay. This is a very good question. It's got multiple layers, okay? So if you are thinking about being an engineer or something like this, these are the things you have to think about. This is exactly why we're doing this, because there would be a better solution here, and I kind of touched on why there would be a better solution. So first things first, let's kind of sketch this situation, okay? So we've got 22 here, we've got 51 here, and we've got 18 on this side, 18. Now, I don't know where this 18 is going to attach. It's less than 22, right? So it could probably, conceivably, it could kind of attach here or attach over here somewhere. Do you see that? So here are two possible triangles, because this is an ambiguous, the ambiguous case section. So it probably could attach up here, or it could attach down here to make a larger triangle. Are you guys kind of seeing those two possible triangles there? It's a bit of a different orientation than some of the drawings that we've been drawing before, right? But you could have two possible triangles, it looks like. So let's just see if that's true. Calculate the possible distances. All right, now again, we're oriented just a bit of a different way here. So this is going to be 51 degrees here, and this is going to be 22. So remember the B sine A? That is going to give us the minimum distance from here down to the slope. That would be a 90 degree, right? B sine A is going to give us the minimum, forming a 90 degree angle. So let's find out what B sine A is. That's going to be 22 times sine of 51 degrees. So we'll get our calculator out here, and we will maybe do that. So turn it on. Okay, let's make sure we're in degrees. Oh, I'm in radians from my other math class, so I'm going to put that in degrees. Okay, you should have a D or a DEG on your calculator. I'm going to do 22 times sine of 51. Boom. 17. Okay, this is good because the minimum distance that I would need to make a right angle triangle is 17.1 meters or so. And I have an 18 meter beam. So that's good. So I have one that's long enough. So I'm going to say 17.1, 09, let's go to 1 meters. And so 18 is definitely a little bit bigger than 17. So guess what? This would be 17, and this is not drawn to scale very well. But the 18, okay, because it's less than 22, the 18 could be drawn here, 18, or it could be down here, 18. Right? The question says now, calculate the possible distances. So I want to find out what this distance is, right here, x1. And I want to find out also what this distance would be, x2, let's say, or the second distance, okay? All right? Okay. So now we can use, well, what can we use? We can use sine law to find out this maybe? Can we use cosine law? What do you guys think? I think in the next section we're going to do more about solving triangles. We're going to get more practice, but we're going to try and find out these distances. So those of you that tried this question, what did you do at this point if you think you got it? Because there's some that didn't get this. But did anyone get this question? And can you tell me how you tried to solve for x1, x2? Anybody want to offer an idea? Okay. Did anybody get this question? Yes? Okay. Yes? Okay, what did you do here? Did you use sine law or cosine law or something else?
I used sine law first and then cosine.
Sine law and then cosine law. Okay, let's check it out. I think that's probably what we're going to have to do. Notice that we have a side length and its opposite angle that's known. Okay, that's really good. That's really good. So what I can do, because I'm given 22, I can actually find this angle, right? I could find this angle. And that would let me find, this length here. So let's clean this up a little bit. Let's get rid of some of this stuff. Okay, I'm going to solve for, I'm going to try and maybe, let's do this. Let's clean this up a bit. Okay. So sine law would look like this. I'll do red. So I'm looking for an angle, so I'll do sine up on top. So sine of 51 over 18 equals sine of, let's call this B, sine of B over 22. Okay, so I'll multiply both sides by 22, and then I'm going to do sine to the negative 1. So let's do some calculations. 22 times sine 51. You guys should be writing this down with me. I think none of you have got this, I guess, only a couple. So you should be writing this down with me. Okay, so do this. Get your pens going. Don't be sleeping over there. 22 times sine of 51. Okay, we did that divided by 18 is 0.9498. 0.9498. So now I'm going to take the second function sine of this number to get B, right? That's how you rip away this sine function, is to do the second function or inverse sine. So let's do that. Second function sine of the answer is 71.77, or 71, let's say 0.8. Actually, let's just go to the nearest degree. No, let's go to the 0.1. 71.8 is good. So B, angle B, is 71.8. Okay. Now, does that look like the 71.8 degrees? Does that look like it could be this one, or does it look like it could be this angle? Right? Because we've got two possible triangles here, right? So is it this angle, the 71, or is it this one, do you think?
The bottom one.
Okay, the bottom one. Why the bottom one?
It's not lots of twos.
Right, because this one is going to be obtuse probably, right? This is going to be super small. This is going to be super big. So 71.8 is going to be this one. All right, so we've got that, 71.8. Now, the big deal here is to find this side length here on the side, right? That's what we're going for. So actually, you can use cosine law here, but you can also use sine law again, because you can find out what this angle is, and then you can use sine law again to find this side. So let's do that. So I'm going to find that third angle. So 180 minus 51 minus 71.8 is 57.2. So this is 57.2 degrees up there. Okay? All right. So I'm going to go now. I'm trying to find this side length. This is going to be x2. So I'm going to go x2 over sine 57.2 equals 18 over sine 51. I'm going to multiply both sides by sine of 57.2. And let's see what happens there. Okay. So sine of 57.2. Oh, what's going on here? Okay. Let's try this again. 18 times sine 57. Hang on. Sine of 57.2 times 18 is 15 divided by sine of 51 is going to be 19.5. We'll say 19.5. So x is 19.5 meters. All right. Now that's going to be x2. Okay, so that's one part of our answer. The other part of our answer is going to be to find this smaller side. Okay. So it's a little more work, but not a ton. Let's focus on this little triangle. This is the second one. So the first triangle that we solved was this one highlighted in blue, and this was the 71.8. Notice that this also has to be 71.8. Okay, this and this is like an isosceles triangle here. So this angle right here has to be the supplement for 71.8. Okay, so focus in on here. So 180 minus 71.8. 180 minus 71.8 is going to be 108.2. Okay, good. 108.2 degrees. So that's going to be this angle right here. And so what we can do is we can figure out what this angle is, and then we can solve for that little side there. So 180, what do we got here? 180 minus 51 minus 108.2. Did anybody do that? Thank you. 20.8 degrees. Okay. Other people got that number too? 20.8. So this 20.8, awesome, 20.8. Then I can use the sine law to find x1 because I'm given all sorts of other patterns. So x1 over sine of 20.8 equals 18 over sine 51. That's our original pair that we're given. And so sine of 20.8, multiply both sides by sine of 20.8. And let's see what we got here. All right, let's clear that. So 18 times sine 20.8, oops, that's 5, not 8, 20.8 divided by sine of 51. Good. 8.2? X1 is 8.2 meters. Okay, so these are the two possible distances that this could be fastened down the hillside. So as we mentioned before, we have two possible positions. So this is 8.2 meters and this is 19.5 meters. Now, so those would be your first two parts of the answer. The question says, where do you think, like what's your recommended distance? Where should that support beam be fastened to the mountainside? And we mentioned a little bit of that before, right? This shorter distance here, that's not going to give you as much support as if this support beam was down a little bit further down the hill, right? So these are your two answers, and you would say, I would put the support beam 19.5 meters down the mountainside so it provides a little bit more vertical support, right? Because if it's up here, this is not a lot of support for the end, right? If it's like this, but if it's down like this, you've got a little bit more vertical support, something like that. Yeah, make sense? Yeah? It's early Monday morning. Everyone's still waking up or what? No? Okay? Okay. All right. That's your question number. Now, does that match, those answers match with the back of the book? Anybody check? Did you get that? Yes? Okay, good. Those of you that did it. All right, that's number 9.